there, I'm Diane, and you wanted to know how to do the correlation coefficient for this data, where here's the x from 2 to 10, and here's the y, and that's year and temperature. So what we need to do the correlation coefficient is to calculate x squared, y squared, and x times y for each of the pairs. So for example, 2 squared is 4, so that's x squared for the 2, and 40.66 squared is 1,653. And then x times y, so 2 times 40.66 is 81.32. So you would do that for all these pairs. And then you also need the sums. So the sum of the x is 54, the sum of the y is 269.22. And then we also have the sums of the x squared column, y squared, and x times y. And then this is one way. There's a few different ways to calculate the correlation coefficient. The one I'm using is the one you see at the bottom here. And so in order to get those components, we need these three equations. So first we need the sum of x squared. And so that's the sum of this x squared column, 384, minus the sum of x and that whole quantity squared. So that's this 54 squared divided by n, and there's 9 pairs altogether. So divided by 9, and that gets us 60. And then SYY is the sum of y squared. So that's 8,497 minus the sum of y squared, so 269.22 squared divided by 9, and that equals 443.78. And then we need the sum of x times y, which is 1,453.7, minus the sum of x times the sum of y over n. So the sum of x is 54, the sum of y is 269.22 divided by 9. That gets us negative 161.6. And then now we have everything we need for the correlation coefficient, and that's negative 161.6, that's SXY, divided by the square root of 60, which is SXX, times the square root of SYY, which is 443.78. That gives us negative 0.99. So that's almost a perfect negative relationship. And if we did the scatter plot for x and y, we would see that all the points lie almost on a line. And so that's how you do it. Sorry, this looks a little blurry. I don't know why Wyzant uploads it that way, but let me know if you have any further questions. Thanks. Bye.